Okay, here's another problem. And so we have a peg confined. It asks for the velocity of a peg, and it is given that you know these numbers. Okay, so do you need a free body diagram? Well, it's not clear because it's not a dead giveaway. So count the degree of freedom. All right, so can something move? Yeah, this slotted arm here can rotate. So that's 1 at least. If you stop it from rotating, the peg can't move, nothing can move, so it's 1 degree of freedom. What 1 degree of freedom means is if you give me one velocity, I can find any velocities. You do, because you're giving me the omega. Also, if you give me one acceleration, I can find any acceleration, and you do, you give me an alpha. So for this problem, I don't need any free body diagrams. So anyway, it might be easier to use the methods that we've had before, but since we're in rotating bodies, let's go ahead and use that one. I'm going to use special points in this case. First thing to do is to find out how many rotating bodies there are, and there's one rotating body, so we'll call it body 1. Now look for the number of special points. There's a special point here at O. It's special because you know something about it. It's in permanent contact with the ground. And also it's touching two bodies. It's touching the slotted body and the ground. Point A is also special because he's touching more than one body. He's touching the ground, sliding along this edge, and touching the slotted body. Also, you know something about it. It's going vertically only. Right? So O and A, there are no other special points. Because there's two special points on the slotted body, you're expecting to write one special point equation. So let's go ahead and do it. What I'm going to do is choose O and A. So since I want to find the velocity of the peg, that's A, I'm going to start by saying the velocity of A equals, the only other point that's on the body is O, so I'm going to choose the velocity of O plus omega. Now the omega is of the body that they share. There's really only one body, so obviously it's body 1. But point O and A share that slotted body, so that would be omega of the slotted body. I'm going to write S for slotted body. Cross R, and it has to go from this point, the one on the right-hand side, to the one on the left. So it's got to go from O to A, plus VREL. Okay, now, are the VRELs 0? You know they're 0 if points O and A never get any closer or further apart from each other. But in this case, they do. A looks like it's going to be getting further away from O as it rotates counterclockwise like this. So therefore, the VRELs are not 0. Okay, I've written the one special point equation that I'm expecting. So now what I'm going to do is plug in values that I know. So the velocity of A, well, I don't know how fast it's going, but I'm going to call it little va. But one thing I do know is it's got to be going vertically upward because it's crammed into that slot. So that would be in the J. Okay. The velocity of O, what do you know about O? Well, O is in permanent contact with the ground. The table then says that O has got the same velocity as the ground. The ground is not going anywhere, so that's 0. Okay, omega. Now, the slotted arm has simple angular velocity. If it has simple angular velocity, then I paint a line on the body, I paint a line on the ground, and I define the angle between them, and the rate of change of that angle is equal to the angular velocity. That's what the book is calling omega. So this guy is equal to omega. So that would be the value W. I have to determine what direction. So if theta dot is getting, if theta is getting bigger, theta dot is positive, If theta dot is positive, it's going counterclockwise the way the arrow shows, and that would be in the k direction. I guess I should have said I is right, j is up, like usual, and then k is counterclockwise. All right, so this would be a positive k. Cross. Okay, R from O to A. All right, I don't really know this distance here, so I'm going to call it L. And from R to A is going to equal L cosine of theta in the I direction, positive I to the right, and I'm going to go a distance L sine theta, and I'm going to go up. Up is a positive J. Now let's get the VREL terms. Okay? The way you get the VREL terms is you pretend like you're standing on the body that they are sharing. So you're standing here on this body. So what that means is everything around you looks like it's moving, but the slotted body doesn't, because the slotted body is beneath your feet and it stays beneath your feet. Then you ask yourself, what is it that you see happening? I see O sitting still because he's at the end of a rod that I'm standing on. But A looks like it is moving in this slot. And so he could be going either out the slot or he could be coming in the slot, one or the other. But he's got to be in the slot. That's what I see. So I'm going to write that down. So what I see is some speed. I have no idea what the speed is, so I'm going to call it little VREL. But one thing I do know is it's either going out the rod or in the rod. I'm going to assume he's going out the rod, and so the direction that he's headed is going to be cosine of theta to the right, and he looks like he's going up a little bit, sine of theta, up. So that would be out of the rod. If you wanted to say he was going in the rod, then this would be, he'd be going left and down. And so there'd be two negative signs there. Okay, but let's do out the rod, because I don't like negatives. Okay, so that's assuming he's going out the rod. Okay. Now, the next thing that you're going to do is the cross products. So let's go ahead and do the cross products. So VA J equals, let's see, WL cosine theta. K cross I is equal to a positive J. And then I have another one, omega L sine theta. K cross J is a negative I. And then I have these other terms, VL cosine theta I plus sine theta J. Alright, so extracting the equations, you have 0 i's over here. That equals minus WL sine theta plus VREL cosine theta. And then the j's, VA, equals WL cosine theta plus VREL sine theta. Okay, so the top equation, I'm going to solve that guy for VREL, because I know omega. So VREL is equal to W omega L sine theta divided by cosine theta. Then use that in the bottom equation and you get VA, the speed that I'm looking for. VA is equal to WL cosine theta plus VREL, that's WL sine theta over cosine theta times the sine of theta. Alright, so if you simplify it a little bit, dA equals WL cosine theta plus sine squared theta over the cosine of theta. Now they wanted it in terms of W, which I have, theta, which I have, but I have L instead of B, so you need to find the relationship between L and B. So you ask yourself, is there one? Yes, of course, because there's 1 degree of freedom. If you know one distance, you know you can find the other distances. So in this case, that's not too hard. It's a right triangle. So L cosine of theta is equal to B. So L is equal to B divided by the cosine of theta. So I'll put that in over here. So if you take this and put it in right over here, you'll have everything in terms of theta, B, and omega, theta, and B, like they wanted. If you really want to simplify it, it would be W, or omega, B, omega B, times 1 plus sine theta over cosine theta squared. There we go. Okay, so that's the first one. To do the acceleration, you're going to mimic the velocity equation. So I'll pause. I'll come back and do that again.